The objectives for this video are to learn how to construct a confidence interval for the estimate of a population proportion and how to calculate the margin of error. In a clinical study for a pain medication, 26 out of 558 participants experienced dizziness. Find the 90% confidence interval estimate of the proportion of the population that would expect to experience dizziness while taking this particular medication. The sample proportion, p hat, is calculated by dividing the number of sample units that possess the characteristics of interest by the total number of observations or the sample size. The sample proportion of study participants who experienced dizziness was 26 out of 558. This gives us a sample proportion of 0.0466. The sample proportion is an example of what is called a point estimator. The problem with point estimators is that the likelihood that they are equal to the population parameter that they are intended to estimate is very low. We compensate for this by constructing an interval. We will calculate a margin of error and add that value to the sample proportion, and then subtract it from the sample proportion. This will provide for us a lower and an upper boundary in the form p hat plus or minus e. The margin of error is calculated by the formula E, which is the symbol for the margin of error, equal to z sub alpha over 2 times the square root of p hat q hat over n. So we will need to determine an appropriate z-score. The symbol q hat represents the complement of p hat, so it will be calculated by subtracting the value of p hat from 1. If we examine the t-distribution table, we will see that the bottom row contains z-scores. So we will find the column that gives us the probability distribution values for the 90% confidence interval, and then on the bottom row, locate the value of z, which will be 1.645. The calculation of the margin of error then becomes 1.645 times the square root of 0.0466 times 0.9534 divided by 558, which gives us a margin of error of 0.0147. Adding that to the sample proportion gives us a right endpoint of 0.0613. Subtracting the margin of error from the sample proportion gives us a left endpoint of 0.0319. So we now have an interval that spans from 0.0319 to 0.0613 that we can use as an estimate for the population proportion. This interval is interpreted in the following way. It can be stated with 90% confidence that the proportion of the population that would expect to experience dizziness while taking this particular pain medication is between 0.0319 and 0.0613. We can also interpret this interval in a percentage format. It can be stated with 90% confidence that between 3.19% and 6.13% of the population would expect to experience dizziness while taking this particular pain medication. In this video, we learned how to construct a confidence interval for the estimate of a population proportion. We also learned how to calculate the margin of error.